Hi everyone, welcome back to Math 245. This lesson is all about what we call probability distributions. So we have a bunch of definitions here which may seem a little bit overwhelming at first, but no worries, we will do some examples and hopefully that will get you all squared away. So a random variable x denotes the outcome of a theoretical experiment with numerical outcomes. So x is just a variable here. For example, if our experiment is to flip a coin twice, there are 4 possible outcomes: 2 heads, 2 tails, or one of each, heads then tails, tails then heads. These are our only 4 possible outcomes. So if I define my variable x to be the number of tails that I flipped, then there are 3 possible values of x: 0 tails, 1 tail, or 2 tails. Therefore, the probability of each of the random variable is x equals 0. The probability of getting 0 tails is 1/4. The probability of getting 1 tail is 2/4 or 1/2. And the probability of getting 2 tails is 1/4. So this right here is known as the probability distribution. The probability distribution is a table that shows the probability of each outcome of an experiment, or in other words, it shows the probability of each value of the random variable. Since x represents all possible outcomes of the experiment, the probabilities of each value of x should, and always will, add to 1. In the example, we see that these probabilities added together, 1/4 plus 1/2 plus 1/4 is equal to 1. That's because these 3 values are the only values that x can take on. So this table right here. It's not a table in this case, but this information right here is the probability distribution. And again, our probabilities should always add to 1 if we are accounting for every single value of x. So let's do some examples to get familiar and comfortable with probability distributions. Suppose there are 3 lollipops and 5 chocolates in your kitchen drawer. You decide to randomly select 3 and observe the number of lollipops that you draw. Define the random variable x. So I'm going to define x as the number of lollipops that I draw. Number of lollipops I draw. So what values can this take on? Is it possible to get 0 lollipops? Yes, it is possible for me to draw 3 chocolates and 0 lollipops. So x could equal 0. It's possible for me to draw 1 lollipop and 2 chocolates. It's possible for me to draw 2 lollipops and 1 chocolate. And it's possible for me to draw all 3 lollipops. So these are the 3 values that x can take on. Alright, suppose the random variable x has the following probability distribution given in this table, and we want to find the following probabilities. So first, the probability that x is less than or equal to 2. So here, I see that I have 3 values that satisfy that: 2, 0, and -2. So the probability here, the probabilities are given in this column. So I don't know what this situation is, but the probability of getting -2 is 0.1. The probability of getting 0 is 0.2. And the probability of getting 2 is 30%. So if I add this up, the probability that x is less than or equal to 2 is equal to 0.1 plus 0.2 plus 0.3, which is 0.6 or 60%. So for this particular distribution, the probability that x is less than or equal to 2 is 60%. What about the probability that x is equal to 0? Well, that's just one of them, and I see that x equals 0 has a probability of 0.2 or 20%. And what about x is strictly greater than 0? So I cannot include 0 here since I have to be strictly greater than. So I'm looking at 2, 4, and 8. So the probability that I choose 2 is 0.3. The probability that I choose 4 is 0.3. And the probability that I choose 8 is 0.1. This is 0.7, or 70%. So let's see here. If all of these probabilities add up to 1, then we know that all possible values of x are accounted for. In this case, these values do add up to 1. That means that all values of x, or k here, are accounted for. That's a good check to do. All right, let's do one more example. The following probability distribution for the random variable x was created from a national survey based on responses from households on the number of pets in the house. What is the probability that a person from the survey has less than 2 pets? So I see here that my number of pets here is 0, 1, 2, 3, or 4 or more. So these are all of the possibilities that I have for the number of pets, right? I can't have like half a pet, I can't have negative number of pets, and everything above 4 is accounted for by the last column. So these numbers then should add up to 1. Our probability should add up to 1, and they do. If we were to calculate it out, they would add up to 1. And we want to know, what is the probability that a person from the survey has less than 2 pets? Well, if I have less than 2 pets, I have either 0 or 1. So this is the probability that x equals 0 or x equals 1. So this is 0.33 plus 0.12, which is equal to 0.45, which is 45%. So the probability that a person that you randomly select has less than 2 pets is 45%. All right, this was a brief introduction to probability distributions. We have 2 more lessons today, so go on over to those. I'll see you there.